Till now we've been studying properties of images formed by the spherical lenses. Take a moment and go through the properties. One of the properties of an image is its position in space. From these tables, we see that the position of the image changes as the object's position changes. There is an equation or formula which gives us the relation between the objects and the image's position. And that formula is what we call the lens equation. Let me just write down this equation first. This is the lens equation. 1 over f is equal to 1 over v minus 1 over u. In this equation, there are three unknown quantities. U represents the object's distance from the lens, v represents image distance from the lens, and f is the focal length. To understand this, let's consider a case for a convex lens where object is kept beyond 2f1. What will be f here? It is the distance between the optical center O and the principal focus of the lens. This distance will be equal to f. And this distance will be u and this will be v. This lens equation is valid for all spherical lenses as well as for any position of the object. However, we can't use this equation directly. There are some sign conventions that we must follow before using it. And what are those conventions? We follow the Cartesian sign conventions. Do you remember the Cartesian sign conventions we'd seen for spherical mirrors? Here they are. The object is always placed to the left of the mirror. Distances are always measured from the pole. Distances to the right are positive and to the left are negative. And distances above the principal axis are positive and below it are negative. The concept is similar for lenses. For our lens, we assume the optical center to be the origin. So the first convention we follow is that we always keep our object to the left of the origin or the optical center. Can you guess the second convention? Second convention that we follow is that we measure all the distances from the optical center. For instance, if we take this point on an object, then the distance of this point from the lens is measured from the optical center of the lens like this. The third and the fourth conventions are easy. Here they are. I'm sure they're self-explanatory. What is that we measure above and below the principal axis? Yes, the heights of the object and the image. And what do we measure to the right and the left of the optical center? Yes, the positions of the object and the image. But according to the first sign convention, the object is always kept to the left of the optical center. This means that the object's distance from the lens will always be negative. But the image distance could be positive or negative depending on its position. What about the focal length? Well, the focal length can be measured on both sides of the lens, right? Isn't it the same on both the sides? Which is why there is a fifth rule that tells us the sign convention for the focal length of a lens. For a convex lens, focal length is considered to be positive and it's considered to be negative for a concave lens. So these were the 5 sign conventions that are used for the lens equation. In the next video, we will see some examples based on this equation. See you there.